Number 32. Consider the graph of x squared minus 4y squared minus 4x minus 24y minus 33 equals 0. The vertices of the graph are a comma b and c comma b. If a is less than c, then a equals what? So, first thing we have to do is get this equation into a standard form. And so, the way I'm going to do that, I'm going to get all of my x's together and all of my y's together, and then all my constants onto the right-hand side. So, first thing I can do is I just have x squared minus 4x, and then minus 4y squared minus 24y, and that equals 33. So, all this stuff is just rearranging, and then here I just added 33 to both sides. So, next thing I can do, I'm going to make it so all of my x squareds on my y squareds have a coefficient of 1. So, my x squared, that already works. For the y squared, though, I have to factor out a negative 4. And so when I factor out a negative 4, I just get y squared. And then factoring a negative 4 out of negative 24y, that gives me a positive 6y. And together that equals 33. So next thing I'm going to do, I'm going to complete the square for each of these cases. And this will get me to the point where I can just get us to the standard form. So completing the square with the x squared plus 4x, the way you do it is you take the x coefficient, you divide it by 2, and then you square it. So 4 divided by 2 is 2, and then squared is 4. So I have x squared plus 4x plus 4. And then for the y's, so it's going to be a little bit different, but in the end, it's 6 divided by 2 is 3, and then squared, that's 9. But I can't just do this to the left-hand side and not do anything to the right-hand side. I have to change it around. So I added 4 in this case, so I have to add 4 here. And then I added a 9 in this section, but that 9 is being multiplied by a negative 4. And so in the end, I'm actually subtracting 36. So I have to do that to the right-hand side also. So then if I make both of these squares, x squared plus 4x plus 4, that's x plus 2 squared. And then it'll be minus 4 times y plus 3 squared. And then on the right, 33 plus 4, that's 37, minus 36, that's equal to 1. So the way that this works is whenever you have your hyperbola, and this is in fact what this is, and you know because you have one of your squared terms is positive and the other squared term is negative. That's how you know you have a hyperbola. So it's going to be in this general form when we're finished. It should look like x minus h squared over a squared, and then minus y minus k squared over b squared, and that's equal to 1. So we already have the part where it's equal to 1, so we just have to get things into the denominators. So I'm going to change something real quick. This x plus 2 squared, I'm going to change that to just x plus 2 squared over 1. And so now we have 1 is equal to a squared. And then also, same kind of deal here. Instead of having a 4 right here, I'm going to divide by 1/4. So we have 1/4 is equal to b squared. And so what this tells us, h comma k in the standard form is going to be the center. And so the center of our hyperbola is going to be at, I'm going to change colors so it doesn't get too crowded. So our center is going to be at negative 2, because this is x minus h. So x plus 2 would be x minus a negative 2. And in the same logic, it will be negative 2, and then for the y-coordinate, we're going to have negative 3. All right, so since we have the x squared term as positive, our hyperbola is going to look something, I'm not going to be exact about it, but it's going to look something like this. This is going to be the center at negative 2, negative 3. And the vertices will be these points. It'll be this point right here and this point right here. So we just have to find what those are. Well, the thing about our standard form that's useful is the distance from the center to these points. So this distance right here, this distance is equal to a. And so looking at our standard form, we see that, so it's x minus h squared over a squared. And so if we look at that in comparison to the standard form we have over here, we can see that a squared is equal to 1. And so that means that a is equal to 1. So this distance right here, this is 1, and this distance right here, this is 1. And so now we can find both vertices. So if this point is at -2, -3, and this distance is 1, well then we just take the coordinate that's 1 to the right. So this coordinate would be -1, -3. And then if we go to the left, I just realized I made a mistake. Here, let me backtrack just a little bit. I notice I made a mistake here, but it's okay. So see right here where I have x squared minus 4x, I accidentally changed that to a plus sign. So I'm going to have to fix that real quick. So this should be minus 4x. This should be minus 4x. So then this should be x minus 2 squared. Sorry, just an easy mistake. I just messed up the transcription, but everything else is the same. And so this time, instead of it being -2, -3, since we have x minus 2, the x coordinate of our center is actually going to be at 2. Sorry for the confusion. I just had a little bit of a brain fart. So if this coordinate right here is 2, -3, and we go 1 to the right, this will be 3, -3. And then 1 to the left, that'll be 1, -3. And these correspond in our question to A, B, and C, B. So let's look what they're actually asking for. It says if A is less than C, then A equals what? So it looks like, so A and C are going to be the x coordinates of our vertices, so 1 and 3, and the lesser of these two is going to be 1. So our answer is going to be answer choice A. Alright, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.